Hello, calculus fans. What we want to do now is come up with a formula for the dot product when we have the vectors in component form. That is, suppose we have vectors A and B, and we know the components of these vectors. We want to find a nice expression for A dot B just in terms of those components. And here's the key, we want to be able to do this without using the angle between the vectors. We already have a formula that tells us the dot product in the event that we know the angle. Let's do it without the angle. All right, what we'd like to do is apply the law of cosines to the angle theta in this picture. So here you see we've got the vectors B and A, and then on the third side we have A minus B. You'll notice that if you take the vector B and you add it to A minus B, you should get the vector A. So this picture works okay. We're going to apply law of cosines to the angle theta. If you're not familiar with the law of cosines, I would recommend that you go look this up. It's something that you will have learned in pre-calculus, and sometimes it gets a little lost along the way. So the law of cosines, as applied to angle theta, will tell us that the length of the opposite side, which is A minus B, if we square that length, that will be equal to the sum of the squares of the lengths next to theta, so that's length of A squared, length of B squared, minus 2 times the length of A, length of B, cosine theta. Now what we should do now is recognize that this expression, length of A, length of B, cosine theta, that's just A dot B. So now we have that the length of A minus B squared is equal to the length of A squared plus the length of B squared minus 2A dot B. Let's solve for A dot B in this equation, and this is what we'll get. All right, so we solve for A dot B, and we get 1/2 the quantity length of A squared plus the length of B squared minus the length of A minus B squared. Now we'll do a little bit of algebra, work out what each one of these pieces is. Length of A squared turns into A1 squared plus A2 squared plus A3 squared. You see, we know what A and B are. We know their components. Length of B squared turns into B1 squared plus B2 squared plus B3 squared. And finally, length of A minus B squared turns into this. Notice that we've distributed the minus sign. We do a little bit of algebra, work through everything, distribute some minus signs. And what we end up with is A1 B1 plus A2 B2 plus A3 B3. So this is a really nice expression for the dot product of A and B when we know the components. We started by defining the dot product in terms of the lengths of the vectors and the angle between them. Now, if we have vectors in component form, we can easily compute a dot product without knowing anything about the lengths and without knowing the angle between them. So this is a very nice expression. So we can give a theorem that says that the dot product of A and B, given in component form, can be gotten by just multiplying the corresponding components and then adding up those products. And of course there is a dot product of two-dimensional vectors that's similarly defined. Okay, that's all for now.